Good evening. My name is Anurag, and I'm here to present my final project presentation. That's analysis of poverty in major cities of Ohio. Uh, the goal of this project was to analyze the poverty situation in Ohio, basically in the major cities of Ohio. The data was collected from the United States Census, and the data was available, and other data was available from reliable sources. Another goal is to predict the relationship between the various covariates and how they affect poverty. The significance of this project is to shed light on the various factors that affect poverty in Ohio and to create a relationship between some of the independent parameters. The objectives of the project is to visualize poverty level in 19 major cities of Ohio based on nativity using histograms. And the second objective is to generate a hypothesis and prove a link between poverty and its covariates. Third objective is to build a unique model to predict the poverty level based on many independent variables using multiple regression. So what did I do here? I collected poverty data from 19 major cities of Ohio from the official government sources, US Census data specific. Then I collected variable data from reliable sources that I've referred based on instinct that I think it might affect poverty level. So that's how I collected the data, and then I visualized the poverty data based on type of population using histograms. Generated hypothesis and then perform multiple regressions. So this is the data that I'm testing. This is all of the data I've got from the US Census, and I'm basically using this for my to construct my model, and I'm using all this to make my histograms. So those are the 19 cities. It's from I've chosen the cities based on the population and sizes and demographic. So I think it might give an idea of the state. So this is my whole data from the major data I'm going to test. So coming to data visualization. So this part is explaining the first two columns, that is born in US, native to US and foreign people. So it shows that native people have more. It's obvious because people who are born in US are little, there are more number of people. So obviously the poverty level is more in that section, and because of that I decided to split them. And so among native people I've split into born in US and born outside US. So born in US there are more people obviously, and born outside US there are less, because people who are from US and who are born outside US, they'll be obviously financially more stable. So that's the conclusion I make out of it. And from foreign people, I split into two categories, that is naturalized citizen and not a citizen. The natural citizens are one who came to US and became a citizen, and not a citizen is one like all of us. So so basically it shows that the one who have become naturally citizens, they are more financially stable, and not a citizens struggle and they come up with later on. So this is the covariates that I'm going to test with my data. So these data were randomly selected based on my instinct. I collected data from various websites. So so that's first is total area, schools, college, university, hospitals, shelter homes, and all these were with my instinct. Then I went I got a little bored, so I decided to make out of scope and make McDonald's, Starbucks, Pizza Hut, and stuff to see how it affects, or is there any correlation or link. Okay, so this is my hypothesis. My null hypothesis is to show that the respective covariate is not related to the poverty level. And the alternative hypothesis is the covariate is related to the poverty level. So the goal of the hypothesis is to prove that the covariate are indeed related to the regression model, therefore reject the null hypothesis one by one. Standard alpha is used 0.05. So the first thing before I conducted my analysis is to perform a scatter plot in order to exclude some of the covariates. But unfortunately, all of the variables I've used were showing a linear positive correlation, so I had to select every one. I couldn't reject anything because all the correlation values were more than 0.5, which is a very good model. So this is first two, and these are the rest of the variables, which all shows me a linear positive correlation. So the multiple regression approach. So data was tested for below poverty level. I used backward selection approach and using one covariate at a time. Started with full model including all system variables. Removed the least significant one, which has highest p-value, from the model one by one, and then came with the equation. So this is the percentage of, this is the R-square value before the analysis. So it showed me a really good R-square value. So this is it was really good. So I thought like, okay, this model might be a pretty good one. So this is how I started with. So this is after the regression model. So after regression, I can see a dip of 0.01 in R square value, which is not bad at all. And so you can see the equation I created in the final after the jump gave it to me. So this is a below poverty level equation. It shows me that schools, universities, and GameStop is apparently affecting poverty level. So it is quite, and it's 97% accurate. So to test this equation, okay, before that I've checked for residuals. So here I've come up with some, I don't know, it's some kind of a complication because some of the residuals were uniformly distributed and some of them were like concentrated in the beginning. So it's not like random spread. So I kind of came up with the conclusion that below 150,000 poverty level, the model is it gives like the model is more what do you call solid for the poverty level below 150,000, and the residuals were plotted, which is not exactly normal, but it's kind of like normal plot. So there's some outliers here and there. So that's, I think it's all right. It's all right. So in order to check the equation, I performed F test on the model. So it's basically I performed another hypothesis for the equation that the model equation is not better than using means, because we can use means and we can predict. So my hypothesis was a null hypothesis was to model equation is not better than mean, and the alternative was the model equation is indeed better than mean. So as we can see, the F value here, which is less than 0.05, and which proves that the equation is indeed like useful. So the hypothesis is, we reject the null hypothesis. So the results and conclusion. So the data visualization gave us the idea of the group of people needed more attention from the state government. The initial null hypothesis was rejected for the number of schools, colleges, and GameStops, because that's how the equation was predicted. And but we failed to reject the null for the rest of the variables, as the regression model didn't give the p-value which was needed. The equation built is 97% accurate and better than using means. That's proved by test, which therefore can be used to break the below poverty level, as I've shown you earlier. Since the model was very strong, which is high R square value, so I think we can include more variables since the model is so good. So we can, there's a scope of building a bigger equation, a bigger model. So future work in scope. To perform the same analysis on foreign people and native people below poverty level and come up with new models and new equations, that could be like give us some more interesting variables. Create more variety and interesting variable data for the cities, like example include vehicles, weather data, restaurants, clubs, and make more models. That's it. Well, those 19, like I could have added more cities because I wanted more rows. So because my data was comparatively smaller, the thing is, the more cities I added, the less number of data I was getting. Like most, like Walmarts were 0 and GameStops were 0 in many cities. So all of the data which I was getting was like literally there's no data in the smaller cities. So I just included 19 cities, which I felt was more significant. They are like more prosperous cities, like more number of population and more people. The data is actual poverty level. I mean, it's collected from the US census. It's 2016 data. I could have used some other method, but I felt multiple regression gives me a model. Like I can generate a model. That was my goal of the experiment, to create a model and predict the poverty level based on the different variables. So that's why I thought like I would use multiple regression. Yeah. Yeah. That's because I feel like the majority of the data was like probably because it's all linked, and I would say because the data, all the other data were also like because probably most of the variables were indeed affecting the poverty. I think that's the reason. That's why it's so accurate. Yeah. Because not all the cities are like small population. Like I, because the smaller cities have no interesting variables to collect data with, like there were only schools and hospitals and stuff. Because that's the reason I wanted to make it more interesting, add more variables. So that's the reason I chose bigger cities.
Hello everyone, my name is Amino Sinha. Today I'm gonna present a model which will predict the 2017-18 champions of India's Premier League by using Poisson distribution. So